Okay, in this video we're going to be continuing on with our lesson on approximating square roots. So we're going to be defining a few different terms as well as looking at some examples of when you would use square roots or approximating square roots. So first of all, let's look at the few definitions that we need to go over. First one we're going to talk about is what's called a rational number, and we mentioned this a little bit in the last lesson, but a rational number is basically any number that can be written as a fraction. So obviously if it's a fraction, it's going to be rational. Any whole number, like the number 5, you can write it as 5 over 1, so since it can be written as a fraction, it's going to be rational. If it's a decimal, that decimal would have to be repeating, so like 0.3 repeating, or it would have to be terminating, which means it stops. So 0.72, and it stops there. Those, if it's repeating or if it stops, would be considered rational numbers. And then we also throw in the entire list of perfect squares. If you think about it, the square root of 16 is 4, and you can write 4 as a fraction, 4 over 1. So all of those are called rational numbers because you can write them as a fraction. Now, the exact opposite of that is if it cannot be written as a fraction, it's called an irrational number. And maybe hard to think of something that cannot be written as a fraction right now, but we'll see some here in just a minute. But really what you're focusing on is, if you look at the decimal, it's a decimal that does not repeat, and it does not stop. So that decimal would have to go on forever and ever and would never repeat itself. Now if you take all of the numbers that we've talked about, all of the rational numbers, all of the irrational numbers, and put them together in a set, those are called real numbers. So it's any set of rational and irrational numbers put together. And believe it or not, when you get into high school and you start taking the higher math classes, you will start talking about and learning what are called imaginary numbers. So that's something for future reference. So we're just going to focus on rational and irrational. So we're going to look at a list of numbers and we're going to classify them, say whether they are rational or irrational. Okay, so we have a list of 5 numbers right here, and again, we're going to classify them. Are they rational or irrational? So number 1 is the square root of 12. Okay, the first thing you should ask yourself is that a perfect square? Well, 3 squared would give me 9, and 4 squared would give me 16. So it's not a perfect square. So we would call this an irrational number because it is not a perfect square. Number 2, we have negative 0.25, but notice we have the repeating bar over the 25. So since it is a repeating decimal, this one would be rational. Okay, number 3, we have negative square root of 9. Well, the square root of 9 is 3, so this would be a negative 3. And it is an integer. You can write it as negative 3 over 1, so this would also be rational. Next, we have 72 over 4. It's already a fraction, and the definition of a rational number is if it can be written as a fraction, so that would be rational. And then lastly, we have pi. There's our pi symbol. And we talked about this already. Pi is an irrational number. Now, moving on to the next example, we are going to work on approximating a square root. So for this problem, we are going to estimate the square root of 71 to the nearest integer and to the nearest tenth. Okay, so whenever we estimate it to the nearest integer, you want to find the two whole numbers that it is between. So I know that 7 squared would give me 49. 8 squared would give me 64. I'm still not quite there yet. 9 squared would give me 81. So right now, I see that 71 is going to fall right here in between 64 and 81. Now, whenever you round this, whenever you estimate it to the nearest integer, is 71 closer to 64 or is it closer to 81? Well, it's 10 away from 81 and it's 7 away from 64. So this would actually be closer to 64, and when you take the square root of that, you get 8. So if you estimate the square root of 71, it's about 8. Now, if I estimate this to the nearest tenth, okay, we already know it's closer to 8, so we know it's got to be between 8 and probably about 8.5. If you pull up your calculator here, and I'm going to take 71 and take the square root of that. Pull this down a little bit. Notice you get 8.4261 and so on. And nearest tenth, that's the first number after the decimal point. So this would round to about 8.4. Okay, it's almost halfway between 8 and 9. Okay, then moving on to the next example, we're going to be comparing real numbers. So this question says, which is greater? It should be the square root of 5 or 2 2/3. Well, I know the square root of 5 is really close to the square root of 4, and I know the square root of 4 is 2. So that means the square root of 5 would have to be just over 2, maybe around 2.2. I'm estimating that. 2 2/3 is 2.6 repeating. So it's asking which one's greater. So that would be your 2 2/3. Okay, and then the last example we're going to look at is throwing in a variable in there, approximating or estimating an expression. So here we have, it tells us the radius of a circle is about the square root of the area divided by 3. There's your formula you're going to use. It says the area of a circular mouse pad is 51 square inches. They want us to estimate the radius of the mouse pad to the nearest integer. So I'm going to go ahead and just take the formula they gave us. The radius is the square root of the area divided by 3. They tell me the area is 51, so I'm going to take this 51 and plug it in for the A, which is area. So the radius equals 51 over 3. And as I start to solve this, 51 divided by 3 is 17. So we're really estimating the square root of 17. But I know the square root of 16 is 4. So I know the square root of 17 has to be really close to 4. And since they just want us to estimate it, we're going to say that that is about, once that squiggly equal sign, it's going to be about 4 inches, the radius of that mouse pad.